My dear students, you are welcome. आज हम लोग सॉलिड स्टेट पढ़ने जा रहे हैं. सॉलिड स्टेट, you know, matters exist in different states, out of which solid is one. Solid is basically of two kinds. One is called crystalline solid and another is called amorphous. Crystalline solid is also known as true solid and amorphous solid is also known as pseudo solid. Not true solid, that is called pseudo solid. Further, crystalline solid is classified into four major parts. One is called ionic solid, another is called covalent solid, third one is metallic solid, and fourth one is molecular solid. So these are four in number. And amorphous solid has no branches. Now we will study each of the solid in detail. First of all, what are the characteristic property of crystalline solid? Crystalline solid. Crystalline solid is one which has definite characteristic geometrical shape. It has definite regular arrangement of particles. It has definite regular arrangement of particles. Particles in solid state means atoms, ions और molecules. Particles का मतलब एटम से होता है, मोलिकुल से होता है और आयन से होता है. So it has definite regular arrangement of particle, that is definite characteristic geometrical shape. Now second, it melts at a sharp and characteristic temperature. It melts at a sharp and characteristic temperature. Characteristic temperature. It does mean it has fixed melting point. This means that it has fixed melting point. High melting point भी होता है. Now it shows cleavage property. When cut with a sharp edge tools, they split into two pieces and the newly generated surfaces are plain and smooth. So it shows clean cleavage property. It shows clean cleavage, that is newly generated surfaces are plain and smooth. Fourth one, the fourth property, it is anisotropic in nature. It is anisotropic in nature. What is the meaning of anisotropic? Anisotropic in nature. Anisotropic means different physical constants in different direction. So all crystalline solids are anisotropic in nature. Anisotropic in crystal is due to different arrangement of particles along different direction. Now we can see these particles like this. Like this. This is the arrangement. And here is the smaller particles. Like this. We can show it, the anisotropic nature, by their structures. How? Along this direction, if we see, if we look over here, this is A and it is B. Along this, what can we observe? इस डायरेक्शन में अगर देखते हो तो यहाँ छोटे छोटे पार्टिकल्स रिपीट हो रहे हैं, या along this बड़े पार्टिकल्स का रिपीटेशन हो रहा. But if we look over here, this is C to D. If we look C to D, what happens? Small, big particles are repeated. Small, big particles are repeated. Big, small, big, and so on. This is called anisotropic in crystals. This is due to different arrangement of particles along different direction. Therefore, anisotropy in crystals. Anisotropy in crystals. It is due to different arrangement of particles along different direction. Next, it has long range order arrangement. It has long range order